Somewhere in Australia right now, an animal is pooping in perfect cubes. Not round pellets, not shapeless clumps, cubes, with flat sides and sharp corners, like tiny dice made of waste. The animal responsible is the wombat, a stocky, burrowing marsupial native to Australia. Wombats spend most of their lives underground, digging elaborate burrow systems and coming out mostly at dusk and at night. None of that explains cube-shaped droppings, and for years, scientists genuinely struggled to explain how this was even possible. Nothing about a wombat's body looks cube-shaped from the outside. There is no square-shaped exit, stamping out little blocks on the way through. That was actually one of the first guesses researchers had, a kind of built-in cookie cutter, and it turned out to be completely wrong. So scientists went looking inside instead. They studied wombat intestines directly, section by section, tracing the entire path waste travels before it comes out the other end, looking for whatever mechanism could possibly produce flat sides and sharp corners. What they found was stranger than a shaped exit. The real answer was elasticity, specifically how unevenly a wombat's intestine stretches along its length. Some sections are stiff, other sections are noticeably more flexible. That difference isn't random, it's consistent and structured, built into the tissue itself, quietly doing its job with every single meal a wombat digests. As waste moves through these alternating regions, the uneven pressure reshapes it. It's similar to how dough gets pushed into flat planes when squeezed unevenly from different directions, or how a sculptor presses flat tools into clay from several angles at once. Stiff regions resist stretching, flexible ones give way. The result is a series of flat faces meeting at sharp edges, again and again, all the way down the digestive tract, until what comes out the other end looks less like waste and more like something manufactured on purpose. Wombats don't just produce these cubes by accident, either. They stack their droppings on top of rocks and fallen logs, marking territory the way plenty of animals do, with scent, the same basic instinct you see in dogs, cats, and countless other mammals defending a patch of ground they consider theirs. Here's where this stops being just a weird biology fact, though. A round dropping placed on a sloped rock does exactly what gravity does to anything round. It rolls away, downhill, out of sight, out of range, useless as a signal to anyone passing by. A cube does not roll. It sits exactly where it's placed, edges flush against the surface, refusing to slide off into the grass below. That stability might be the entire reason this trait exists in the first place. Wombats have notoriously poor eyesight, so scent marking isn't a backup form of communication for them. It's closer to their primary one, the main channel through which one wombat tells another this ground is taken. A marker that stays put is a marker that keeps working, day after day, undisturbed by wind, rain, or a sloped log, long after the wombat that left it has wandered off somewhere else entirely. What strikes me most is that a digestive system evolved to solve a communication problem, geometry, as a workaround for bad eyesight. This mystery wasn't solved quietly, either. The researchers who cracked it actually won an Ig Nobel Prize in 2019, the tongue-in-cheek award that celebrates science that makes people laugh, then makes them think. It fits the pattern of an Ig Nobel-worthy question, because on paper it sounds almost like a joke. Why would evolution bother making cube-shaped droppings? The prize specifically celebrates research that sounds absurd at first, and turns out to be genuinely rigorous. The mechanism holds up under real scrutiny. Uneven intestinal elasticity, shaping waste through differential stretching, solving a genuine survival problem around scent marking on uneven sloped terrain. No other known mammal replicates this. Not big cats, not primates, not any of the thousands of other mammal species scientists have studied. Wombats remain the only known example of an animal engineering cube geometry using nothing but soft tissue. No rigid mold, no shaped opening, just intestines that stretch unevenly enough to do the job, section by section, every single time, reliably enough that it became the wombat's signature. So right now, somewhere in the Australian bush, a wombat is stacking a small, precise cube on top of a rock. It's marking its territory with built-in biological geometry that no other mammal on Earth can manage, one perfect cube at a time. More of these on this channel. Follow along.